what we saw in the last video was that we were given two decks of cards, A and B, and we wanted to combine these two decks of cards and sort them at the same time. And we were also given the properties that deck A was itself sorted and deck B itself was sorted as well. And so we used that property of these two decks of cards to come up with a rule of helping us to sort these two decks efficiently. And that rule is what I have written here. All right, we always look at the top of the two decks and take the smaller card. And if we keep doing that over and over again until both decks are empty, then we have a sorted final result. And that rule makes up this merge operation here, which takes two arrays, two decks of cards, A and B, and puts them together in sorted order. So I kind of wanted to run through the pseudocode of this, not go too much into detail, but kind of write out what the code would look like. So what I'm going to use is a combination of some Python notation. I'm going to use the keyword def to define a method called merge. We're going to merge these two decks of cards, A and B. So we're going to say that first we should define a result array where we're going to store the result as an empty deck of cards. Technically an empty array, but we can just think of it as an empty deck of cards. And what we're going to say is that while A is not empty and B is not empty, in other words, as long as both A and B contain cards, there's cards in both decks. While there's cards in both decks, what are we going to do? We're going to look at the tops. Like we said in our rule, we're going to look at the tops of the two cards of the two decks. I'm going to say if A's top card is less than B's top card, then according to our rule, what do we do? Well, A's top card is a smaller card, so we're going to take the top card of A. Right, we're going to take this card right here. We're going to take A's top card and we're going to place it onto our result deck. Right, and if we were treating this as an array, this place onto would look something like the append operation. So what's the other case that could happen here? We're going to put an else statement. The other case that could happen is if B's top card is less than or equal to A's top card. And so when that happens, we're going to again look at our rule. We're going to say that we're going to take the smaller card. In this case, it would be B's top card. In this case, B's top card is the smaller one. I'm going to take B's top card and place that one onto the result. Also, I guess one thing I forgot to mention here is that we're going to take A's top card and place it onto the result in this case. We're also going to remove that top card from deck A. We're no longer going to consider it in deck A. So I guess I'm going to make this two steps here. The first step is to take the top card of A in this conditional, We're going to take the top card of A and place it onto the result first. Our second step would be to remove that top card from A. Likewise here, if we take the top card of B, we're going to place that card onto the result, and then we're going to remove that from B. So this is all fine and dandy, but I think one thing you could ask is what happens when one of these is empty? In other words, what if we have a deck of cards, let's say A, which isn't empty, which has some cards in it, but B is empty, there's no cards in B. And we actually ran into that, we kind of ran into that situation last video with the example in the last few cards of the deck. And so our special case to deal with that is that when only one of the decks is not empty, when only one of the decks has cards in it, well, then we're just going to place those cards straight onto the deck. And so what we're going to say is, after here, if A is not empty and B is empty, we're going to place the remaining cards of A onto the result. We're going to take the remaining cards of A and place them onto the result. Otherwise, we know that B is non-empty and A is empty, and in that case, we place the remaining cards of B onto the result. And so that forms the basis for our merge code, right? And so our final thing to say would be to output that result. So I kind of go over what we did here. Is we define this merge function that takes two arrays, A and B, or two decks of cards, and we apply the rule that we came up with last time, which was to always take the top cards of the two, to observe the two top cards of the two arrays, and to take the smaller one. If A was smaller, then we take that top card, place it onto our result, and remove it from consideration. Likewise, if B's top card is smaller. And we had this case where what if neither of these cards, or what if just one of these decks here is not empty, but the other one is empty? Well, in that case, like in our example, we're just going to keep taking the non-empty array and place those remaining cards on that non-empty array onto our result. And finally, we have a result.